So we just went over the unit circle non-graded pop quiz. I don't know, you guys knew it was coming. But just a non-graded practice quiz for the unit circle, which was harder because you had to solve for angles, you had reciprocals, all those things. But guys, I want to make sure that you actually know your identities. So I'm just going to go off to the side and let's see how we did. Now, I did put in your grade for the quizzes, and the #1 error people did was messed up on the Pythagorean identities. So we're going to make sure we spend some time reviewing those. A quick review. Guys, what's 1 over sine theta? Yeah, it's cosecant theta. Okay. So what do I know sine theta is going to also be? Yeah, 1 over cosecant theta. So it's nice. This is the main identity, but we should know the other one as a result. All right, 1 over cosine theta. What is that? Yeah. And guys, didn't we even use that on our unit chart quiz? Just use an idea of these reciprocals to help us out. So then we also know that cosine theta is the same thing as 1 over secant theta as a result. Now these are called your reciprocal identities because of how they are formed. And then we have our next one, 1 over tangent theta is going to equal what, my friends? Cotangent theta. And we also know that tangent theta is 1 over cotangent theta as a result. Then we also use a reciprocal identity that said that tangent theta is also equal to a fraction formed by 2 of the other identities. What are those? Yep, sine theta over cosine theta. The reason why Gregerson said that all the time when I was teaching you unit circles is just so this would be engraved for now. But as a result, we also know then that cotangent theta is going to end up being what? All right, so cosine theta over sine theta. And that's actually helped us on our verifying our trig identities so far quite a bit. So those are all your reciprocal identities. Then you had the next, well, we say the next 3, but really it's the next 9 identities as a result. So we're going to change this, see if I can move this without it getting out of the way. Nope. Tab and exit drawing mode. I'm learning how to run this thing, but it's not the greatest. Okay, so with this one, the Pythagorean identities I'm going to put in purple because purple's my favorite color. When you have the Pythagorean theorem, what do? It's leg squared plus what? Leg squared equals hypotenuse, everything squared. But when we work with this, what do we know the number 1 squared gives us? 1. But everything is really what? Squared. Are you seeing where people went maybe a little wrong on their identities quiz? Things weren't squared. Okay. Just, making sure that we have this one. All right. So for this one, our very first one, and the one that you use probably the most, sine squared theta plus cosine squared theta is equal to what lovely number? 1. But then we use our sub 1s just as much. Do we not? So what else do we know? We also know sine squared theta equals 1 minus cosine squared theta. And we also know that cosine squared theta is going to be 1 minus sine squared theta. And if you memorize those, it makes it go a lot easier. Now, you could not memorize them if you want. That's okay. But you won't get as much, let's just say, time saving as you have to do more work in the long run. Okay, now, here's the one that got people. Guys, tangent squared theta plus 1 equals secant squared theta. The number 1 thing people forgot to do. Squared. Guess what? You're wrong. It's all or none. Okay, I can't go like, oh, did you secant? You didn't do the right thing with the secant. Nope, all or none on this if you know it or not, because they're not the same thing. So with this one, we have our sub 1s that you should know. We know that 1 should equal secant squared theta minus what? Yep, tangent squared theta. And we also know that tangent squared theta can also equal what, my friends? Secant squared theta minus 1. All right, almost done, but we need to do our final Pythagorean identity. And again, think everything is what? Squared, just like the Pythagorean theorem. So we get cotangent squared theta plus 1, really that's just 1 being what? Squared, because it gets you 1, equals what? Squared theta, yes. We got to make sure we square that one as well. Those were the two most commonly missed ones. Otherwise, you guys did a pretty good job on this, but we need to make sure that we have those values. All right, let's do the sub ones real quick. What else do we know? 1 is going to equal to what? Cosecant squared theta minus cotangent squared theta. And we also know that cotangent squared theta is going to equal to, yep, cosecant squared theta minus 1. Those all should be memorized by now. You need to have all of them really well because now we're adding on. We're doing what are called the double angle identities and half angle identities. And you're going to see what that means in just a moment. So these are going to be added, okay? When you are working with these, I need you to know right now, these on the bottom, you don't need to know to have memorized. Because if you know the first ones, you're going to be fine. Now, a couple things we need to remember about notation when we are doing this. First of all, 2 times the sine of x does not equal sine of 2x. When we're doing this one, this is taking our ratio and multiplying it by what lovely number? 2. This one is taking our angle and multiplying it by what? 2. Double angle is what we talked about. Okay, it's the reason why we call it. Those are not equal, so please don't mistake that when you are working with it. Now, the first one is sine of 2x. This is one of the easier identities to memorize that we're going to get today. And I would get this one memorized as soon as possible, but it equals to the following. Sine of 2x equals 2 times sine x times cosine x. So the sine of 2x is 2 times sine x times cosine x. Now, isn't that nice? There's one. But what's the problem with the very next one? Cosine of 2x. How many do you have to know for it? 3. Here's the thing. If you know the first one, you can derive the other 2. It's kind of like your sub-identities in the process. But this one is the one, I'm just going to highlight it, is the one that you have to have absolutely memorized, okay? So make sure you memorize the first one. But the other 2, as you're learning, does it pay to know the ones that are the extras? Yeah, because you use them just as much. So what is the value of sine of 2x that we have to memorize? It's the following. Cosine squared x minus sine squared x. Cosine squared x minus sine squared x. Very easy to get confused with sine squared x plus cosine squared x. So just be very careful with this one. Because which one comes first? Cosine. With the Pythagorean identity, does it matter if sine squared x plus cosine squared x, or is it cosine squared x plus sine squared x? Does it matter which one goes first? No. On this, it does. So make sure it's cosine squared x minus sine squared x. Now, the other 2 identities are derived from this one. So the first one is 2 cosine squared x minus 1. Now someone goes, how in the world do you go from cosine squared x minus sine squared x to cosine squared x minus 1? Very easily. I take the cosine squared x and I substitute something in for sine squared x. Any sub-identities that might work with that? Sine squared x, isn't it this going to be that one? So 1 minus what? Oh, look, I got 1 minus cosine squared x. Look what happens when I combine like terms. I go cosine squared x minus 1 plus cosine squared x. Oh, wait. Did we just verify an identity? Oh, yes. Yes, we did. We got it down. So you just had to substitute in using one of your Pythagorean identities. The exact same process is used for the next one, except for instead of replacing sine squared x, you're going to replace cosine squared x. And this is the other one, 1 minus 2 sine squared x. So what happens is you take your original one, cosine squared x minus sine squared x, and I replace cosine squared x with 1 minus sine squared x. And then if you combine like terms, is that what we get? Yeah. So really the second two are derived. But if you know them, huge, huge time saver. Now, notice it says here, so cosecant of 2x. My friends, cosecant of 2x is the same thing as 1 over what? Yeah, 1 over sine of 2x, which means it's really 1 over what value? Make that 2. Yeah, it'd be 1 over 2 sine x cosine x. So notice the reciprocal functions allow us to create more. Notice I'm not even asking you to memorize this, because if you know that cosecant x, cosecant of 2x is 1 over sine 2x, would you be able to throw all this stuff in just like normal? Don't have to memorize. Did everyone hear me on this one? Don't have to memorize those. But how about the other one? If I have the secant of 2x, we know that's 1 over what? Cosine 2x. The rules don't change. The reciprocal functions won't change. But as a result, could I get 3 other ones if I needed to? Yeah. Do I think I really need you to memorize those? No, because if you know 1 over cosine 2x, should I be able to plug in any of those 3? Does that make sense? Okay, so we're going to pause for a moment. And now we're going to go from double angle to half angle identities. Look at half angles. Instead of going times 2, I'm doing what? Divided by 2. So when you're working with that, you're really using the fact these are your angles. Now this time you do need to know all 3. But some of those half angle identities, you're going to say, when will I ever use them? Here's what you're going to do. They're going to be obvious when you use them. Because these are so different than any of our other identities, you're just going to go like, yep, I'll use that one today. Because it will go so simple. Here's the first one. And I'm sorry, but you do have to memorize all 3 of these. Okay, so sorry about that. You have to memorize that. First one, sine x over 2. Are you ready? It's plus or minus the square root of 1 minus cosine x all over 2. Do you see why it's going to be obvious when you use this one? There's going to be just a giant square root sign there. And someone goes, it has a plus and a minus. Yes, it does. Guess what you can almost ignore every single time? The plus and the minus, because most of the time you'll be squaring to get rid of it, and if you square a negative, it's positive. You square a positive, it's what? Positive. Gotta love math sometimes. Now, if sine of x over 2 is so ugly, what do you think cosine is going to be? Ugly too. Exactly. So it's plus or minus the square root of, now this is where it changes, 1 plus cosine x over 2. Here's the darn problem with this. They're very similar. They're very, very similar to each other. But they're also very easy to recognize. You're like, yeah, I can get that. Pretty simple to do. Now, our next one, the tangent of x over 2, or our half of x, is not square roots, but it's nasty fractions. Okay? So the very first one that you'd have to know is the following. 1 minus cosine x over sine x. So the quantity 1 minus cosine x all over sine x when you are working with it. And we have one more that you should know that's also used. It's the following. Sine x over 1 plus cosine x. So we actually have 2 different ones you can use for tangent. And then once again, they kind of look like they could easily go to be each other. When you work with these last ones, it will be very obvious when you're going to use them. There is like, These last ones are the ones that are like, there's nothing else I can do. I just have to use these. So they're going to be very obvious with the last three when we're going to use those together. Okay, keep this part of your notes there. Now open up your laptops to the homework. There's not tons, so I hope you're okay with that. But you are going to have to be able to do them. So we're just going to work on problems together from your homework. So if you're needing to study the homework what? Problems later. So make sure you have it. So let's see if I can get this to shrink down. And we'll do just in order. We'll do double angles first. And then we'll do one or two problems from our half angles when we're working with it.
It is. We're good.
Number 8's the one I threw. Guys, will you throw this one out on the homework? Can you just cross out for the double angle the secant of 2x? I don't want you to even worry about that one. All right, are you ready for some help? Let's see how these all work together. All right, first one. We have the quantity sine x plus cosine x squared is equal to 1 plus sine 2x. Now, you have to kind of decide what is the kind of uglier looking scenario, and which one do you think is kind of the uglier looking side?
Maybe.
I think left on this one just because I have a quantity being squared. Would you guys kind of agree with that? Just because I'm doing quantity squared. Now, even though I have the sine of 2x, a lot of people are like, oh, can I go there? This would require, if you went from this direction, you're going to end up having to factor. And I don't think I want to factor. Do you guys want to factor right now?
No.
Even though it's a great tool, we don't want to factor. So instead, your very first step is to show that you're going to multiply these two together. Now, FOIL it. Make sure we have our equal sign. So guys, what's sine x times sine x? Sine squared x. Okay, I can write what you just said, sine squared x. All right, so that's sine x times sine x. Guys, then we do outside. What's sine x times cosine x? Sine x, cosine x, plus, cosine x and sine x multiplied together again is going to be sine x, cosine x. If you wrote cosine x, sine x, is that still the same thing?
Yeah.
Yeah, same thing. Plus, our last one, positive cosine x times a positive cosine x is what?
Cosine squared x.
All right, I have a feeling you guys are going to start seeing some stuff pretty quickly here. First of all, when we simplify this, we have sine squared x plus 2 sine x cosine x plus cosine squared x. Would you guys agree? Does anyone see anything else that they can do? Come on.
You could turn the sine squared x plus cosine squared x into 1.
Guys, are we adding these two still together? They're apart. So if you didn't see what Stefano just said, and you could go straight there if you see it. But you guys, could you even rewrite it like this? Sine squared x plus cosine squared x plus 2 sine x cosine x. Is that true? If you did not see that you could go ahead and add those here, now is it easy to see that's equal to what value? 1. So then we can go, oh, that's 1 plus 2 sine x cosine x. So permission is given. If you see it here, you might want to underline it or something like that so you can sit there and justify it. You could go straight to that step if you recognized it. Most people just need to rewrite it first. Would you agree? And there's nothing wrong with that. That's called, are you ready for it? We're going back to pre-algebra, algebra 1 days. The commutative property of addition. Which means can you move it if you're strictly adding? Yes. So, okay, I knew your lives were profoundly changed going back to that level of math again. Paul's sitting there like, I live for this. I wanted to know the commutative property of addition again in my life. All right. He's sitting there like, oh, my day's name. Okay, anyway. Guys, are we almost there? Yeah. Because remember, our goal, and always keep looking back to that other side, our goal is to get 1 plus sine of 2x. Is there anything here that's going to help us with that? Yeah, the 2 sine x cosine x is equal to what? Yeah, so we got 1 plus sine of 2x, which equals 1 plus sine of what? 2x. I got to make sure my 2's don't look like exponents. What do you guys think so far? Was that a doable proof, you guys think? You have to make sure you just multiply carefully, making sure we keep track of our signs. But make sure you have that one. Okay. I think we should do number 4. I think 2 could be easy for you guys. Or easier. So I think we're going to go with 4 for right now. Maybe. Alright, 2 will let you on your own here. Alright, sine of 2x over cotangent x equals 2 sine squared x. Okay, which is the other looking side? I don't know why it's always the left side, but it's always on the left. Okay, but sometimes it is the right side. When we work with this, think about what we're trying to do here. I'm trying to get a lovely 2 sine squared x. So what would we do first? Would we want to leave it as a sine 2x? No, right? What's our only option for sine of 2x? Yeah, so we're going to go 2 sine x cosine x. Excellent. Huh. Does a sine squared x have anything with a cotangent x in it? No. What would be something I could do for that one? What's a reciprocal or an identity I could use that would go with this really easy? So it's cosine, yep. Cosine x over what? Now I've got my fraction. If I divide by a fraction, it's the same thing as multiplying by its what? So I'm going to go 2 sine x cosine x. I'm going to put that over 1 times sine x over cosine x. Now what's the cool thing that happens? Yeah, this simplifies out. We're getting a 1 here and a 1 there. Can I just multiply it together now? And the answer is what, guys? You're going to multiply? Yeah. Yes.
Yes.
Thank you. 2 sine squared x. 2 sine squared x. Now, the nice thing is if you're working with cosine of 2x, you have a lot more options that you could possibly choose from. Or the bad thing is you have a lot more options that you could choose from. So being able to work with those are going to be very much the process. All right, does that kind of give you an idea how to work with these a little bit more? Tyler, would you like to borrow a pen?
Do you have an extra here?
I do. If you just put your phone on my desk, here's a pen for you to use. Make your life a little bit easier. All right. Okay. Hopefully we have time that we can work a little bit more on homework and stuff at the end of class here, but let's go this way. I'm going to go back now to go to your half angle homework. Half angle homework. All right, with our half angle homework, I'm trying to decide. I'll do the first 2. Does that work?
Yeah.
Work the first 2? That means you have 3 left to do. I know, real. I'm sorry. I think what does that give us as a total? We just did 2 out of 7, so that gives you 5. Oh, 8 problems. I think you'll survive on homework tonight. 8 so much. Hello, go back to geometry days, Hannah. Is that a lot?
No.
Okay, moving on. Okay. I just had to bring perspective back to you. Let's bring perspective back. You always had like 20 to 30 problems in geometry. All right. Next one. We have the tangent of x over 2 is equal to cosecant x minus cotangent x. Now, when I'm looking at this, believe it or not, The left side's not the icky side. Which one's the icky side? Yeah, the one on the right for once. So once in a while, we're going to use the right side instead. Now, what would you do when you see this is a cosecant x minus cotangent x? What would be some of the first things that you're willing to try when you do an identity? Switch cotangent? Okay. So that's going to be what? Yep, cosine x over sine x. Do I need to switch the cosecant too, or do you just want to leave it? Switch it, which is going to be 1 over what? Okay. Now what? So they have a common denominator. So I can just combine them, right? I can put the numerators together. So that's just 1 minus cosine x. Which is what? Yeah. So it's the same thing as tangent of x over 2. Isn't that nice? It was just our identity. So don't be, again, until you have these memorized, should these identity sheets be right next to you. So make sure that you have those down. Now, ready for, I should be careful when I say this. I think the half angle ones are easier than the double angles, because the double angles you have a lot more choices, but like half angles you're just like, that's all I'm going to do. This is really the thought process I'm going to apply to it. Look at number 2. It's got 2 times the quantity sine of x over 2 squared equals 1 minus cosine x. Which is the ickier side? I would say this time it's the left. Okay, so we're working with this. What are you going to do? I'm going to square the what? Square root. So here's the cool part. Remember when we had that plus or minus right here? Earlier? What gets taken care of if I'm squaring it? Yeah. And then what is sine of x over 2? So what is it? Square root of cosine x over 2. All right. Now square it. This is where you could put a negative, you could put a positive. It doesn't matter, because when you square something that's negative, it comes out positive. So we get 2 times what? What would I get? If I square a square root, doesn't the square root symbol go away? Over 2. What happens to your 2's now? So we have 1 minus cosine x. Look, we're already done. Anyone like half angle identities? Like 3 or 4 steps. A comparison to our other. Guys, a few things that would help me out reading your homeworks. Make sure every step has an equal sign. Are you guys with me on that? That allows me to know, especially if you run out of space. If you run out of space, just run arrow and create a new column, if that's what you are doing. But keep the equal signs. It lets me keep track of your steps. Otherwise, you need to go step 1, step 2, step 3, that type of thing. Okay, one thing that I need to let you know about an answer key. One of the problems, when Mr. Smith made this answer key years ago, he wanted to show you could do it on either side. So he showed it in 2 different colors. Does that make sense? So like one side would be like in blue, the other one would be in red. You never work on both sides. So it looks really confusing because it looks like you worked both sides. He was just trying to show you, if you did the right side, this is what you would do. If you did the left side, this is what you would do on the answer key. Just so you know when you're reading that, it helps you figure that out a little bit. Just so you keep, that's on the double angle answer key. But make sure that we are correcting it. Some of you need to slow it down and actually go, did I show enough steps? Okay? Am I putting my addition or subtraction signs or multiplication symbol? Like, make sure you have that. All right. What I would love to do now, because we actually do have a little bit of time, I want to take the next 5 to 10 minutes, and I want you to have the last 20 minutes to get homework done, and hopefully you walk out with no homework to do. I would love that extra, if we have time, worksheet that is attached to your notes. that has identities to pull it out. Because I think we just need more practice. I just think we need more practice when we're working with it. So, just blank practice if we have time. This means we actually have time. Now, open disclosure. I haven't proved any of these off the top of my head, so we should hopefully be able to do them together. We're not going to do all of them either. This is just practice. I did not put this in the notes assignments or anything like this because this is just if we have time. And today we're being so dang efficient. We actually have time. Good job, guys. Way to go. But I want you to have practice with you. And so with these, I want you to think about all the different ways that we could be working with our trig identities and being able to work with it, or even making sure that we are reading things carefully in the process. Okay? Are you guys ready to think we can do some of these? Oh, you guys are like, yeah. All right. Let's do, all right, looking at this. Why I always do this to myself. Let's go and you get a pick. All right, so the lonely people who have no one sitting with them, we're going to be picking on you guys to pick the problems you want to do. Grace, out of the first 1 through 4, which identity would you like to see us do together as a class? 3? I think that's a beautiful one. Great job. Now, there's a couple different ways you could do this problem. But I want to know what you guys think are the good ways to do this problem. What are some ways that we can look at? Now, I'm looking at this, and if it's not the left side, I'm greatly concerned, okay, that we're able to work with it or not. Just what would you try? What instincts would you try for number 3? Because right now, is it screaming any huge identities? No, it doesn't. I don't have a Pythagorean identity. I got the sine squared theta, but that's not going to help me if I'm working on the left. Guys, if you're stuck, do what? Change it to sine and cosine. If you're stuck, just try it. Might not be the most efficient method, but if it works, it works. Sometimes it's not the way you want to do it. So secant theta, what would you change that to? Yeah, that's going to be 1 over cosine theta times sine theta all over. Now, you could choose to still keep doing sine and cosine with this. You could also maybe go, oh, tangents, 1 over cotangent. You could choose a couple different things. But let's just keep with our sine and cosine because that's what you guys said. So would you agree with me the denominator is going to end up being sine theta over cosine theta plus cosine theta over sine theta. Now, I think we can do a little bit more that we've been doing this, a little bit more in our head, but still show the steps well. On the top, how would I rewrite the first one? That just became what? Sine theta over what? Cosine theta. All over, now guys, can I get a common denominator this time? Cosine theta plus sine theta. Shouldn't we use a common denominator? If we do the common denominator of cosine theta times sine theta, what would be my first fraction? What would I multiply everything by? Sine theta, right? So sine theta times sine theta is what? Plus, what would I have to do to this fraction to get a cosine theta sine theta? I multiply by what? You have permission to show that step. Like, you don't have to show that you got the common denominators if you're able to do it fairly simply like that in your head. Now, I'm running out of space because, of course, I wrote too big. But when I look at this, the sine theta, I'm going to do it this way, keep my stuff going. I'm going to leave my sine theta, cosine theta in the numerator. But what happened in my denominator? Then we don't cancel out. What's sine squared theta plus cosine squared theta? Equals 1. Yep, 1 over cosine theta, sine theta. Use the obvious Pythagorean identity when you can. Now, I am dividing by a fraction, which is the same thing as multiplying by its lovely what? Reciprocal. So now my next step is sine theta over cosine theta times cosine theta, sine theta, all over 1. Guys, what goes away? Cosine, and then what's sine theta times sine theta? Sine squared theta. Guess what? You got it right. That was actually a really good one to do. Great job. Don't be surprised if you see something like that again in your future. That would be a great one for next week's quiz. Tuesday is kind of what we're thinking for the quiz. Nope, it's going to be actually identities one where you actually prove. It'll be like about easy, medium level. Yes, sir. Yes. All right. Who wants to? I have my solo people here. Jake or Savannah, which one do you want to go and pick a problem? Pick between 5, 6, 7, or 8. Which one would you like to do? You two look at each other, decide if you want. All right, they want 8. Excellent choice. So we have tangent squared x, sine squared x equals tangent squared x minus sine squared x. Ew. How in the world are we going to get there? Now, here's where it goes. I open initiative. I haven't proved this one yet, so whatever we do, we're going to be doing it together. Which side do you think is ickier at this moment? All right, left. Okay. What would you do then? We're going to change this tangent. We're going to change it too. So sine squared x over cosine squared x times sine squared x. Would you guys want to do the left side still? No. Well, here's the cool part. Okay, maybe not want to start it that way. You're not wrong. You're just what? Fixing it out. This is why I love OneNote so much better than the paper days. Try the other side. What would we do for the other side? What do you guys think? Switch tangent again? Okay. So I got sine squared x over cosine squared x minus sine squared x. Okay. What else? Put this over 1. Okay. Now what? Could be. Could we do common denominator? So we got sine squared x minus, I'm going to put this all over cosine squared x. We can do it in one step. Sine squared x cosine squared x. Do you guys agree? Because common denominator, I just did this, right? Everyone with me so far? This is actually the right route to go. You're on the right route. I just want to make sure, does everyone follow where I got the common denominator from and everything? Beautiful. Now, if you're stuck, this is something you guys don't think of naturally. Factor. Look at the numerator. Is there a greatest common factor? What do we got? Don't we have a sine squared x times what? Minus cosine squared x. That's all over what? This is actually, you guys are so good. This is going so well. I don't know if any of you realize how close you are to getting this right. What do I do next? Do what? Yeah, is 1 minus cosine squared x, isn't that one of our identities? Yeah, so that's sine squared x. Okay, we're getting so close. because it's all multiplication now, division and multiplication, the same thing, isn't it really sine squared x over cosine squared x times sine squared x? Guys, what's sine squared x over cosine squared x? You guys got it. That was a harder one. I think you guys did a great job. But the key with this one is like just trusting your math at first and then going, oh, I can actually take a greatest common factor out. That's not one that we commonly do. So when you're stuck, sometimes factoring does work really well. That was a lot of steps. But we got it. Tangent squared x, sine squared x. Ooh, that was simulating. All right, we got one more we need to do. So Simeon and Carlton and Katie, the three of you, eye contact. Pick our next group we're going to do, and it's going to be our last one that we're going to practice, and then you guys are going to go do homework. The three of you get to choose. Simeon, what's your opinion real quick? Do 7? Okay. So we got secant squared theta all over secant squared theta minus 1 equals secant cosecant squared theta. First thing, everyone looks at this and goes, please no. Okay, let's just not go there. But I think most of you are going to catch on to this one pretty quickly. Obviously, the left-hand side looks disastrous compared to the right-hand side, but it doesn't look that bad. But I see a secant squared theta, and I also see here a secant squared theta minus 1. Now, if you think you can do this, you just did illegal math, right? You cannot do it unless it's factors, not terms, so don't do that. So instead, start looking through your identities and think, what possibly could I use? I heard Hannah said I can change the denominator. You guys agree or disagree with her? Agree. What's secant squared theta minus 1? All right. Now what would you guys suggest? Change the secant squared theta to what? Couldn't we just use it quick as reciprocal of it? Well, secant squared theta is also 1 over what? Cosine squared theta. Yeah, and tangent squared theta, exactly. We can change it again because is there an identity for that we love that Gregerson harps all the time on? Which one? Sine squared theta over what? We're almost there. Because if you divide by a fraction, you multiply by its what? What happens to your cosine squared thetas now? 1 over sine squared theta equals cosecant squared theta. What do you guys think? Are they getting anywhere more doable than they were? The key is you've got to know your what? You've got to know your identities. It's just kind of like unit circles. You can't do the unit circle quizzes if you don't know your unit circle, right? So the same idea here is make sure you're memorizing this. You will have a quiz on, right now we're tentatively looking Tuesday, could turn into block day. We'll see when people get back from their trip, okay? So think right now in your head, Tuesday we're going to have a quiz where you're just doing identities and you're verifying them. What we have done in the past, I don't know if we're going to do it in the future, we will have part of that quiz will be like, do you know the identities so far? And you just have to fill them in. Then, a lot of times what we've done in the previous years is we give you the actual identities for the next part of the quiz. So it's kind of a way of like making sure, did you memorize it? Now, if you memorized it wrong, here's the right ones, go for it. So we don't want it to like injure your whole thing. All right.